Operations with complex numbers. We're going to talk adding, subtracting, multiplying, and dividing. Adding, subtracting, very, very easy. Multiplying, fairly easy. Dividing, a little bit tricky, okay? But we're going to get there. So first off, adding and subtracting with complex numbers. This is super easy because it's basically just combining like terms, okay? So what we're going to do is that each one of these numbers has a real part and an imaginary part, okay? So when we look at something in a complex form, it's like a plus bi. This part right here is called the real part because it's a real number. And then this part right here is called the imaginary part, okay? Because it's got an imaginary number with it, right? So what we're going to do to add or subtract these is you just add the real parts and add the imaginary parts. So the 2 and the 5 are the real parts. So I'm going to add those and get 7. And then the 3i and the negative 2i are the imaginary parts. So I'm going to add those and get 1i. Done. All right. This guy's a subtracting problem. So you could think of it as just subtracting, but what I find is most beneficial for a lot of people is start by distributing this negative, make it 3i minus 6 minus 4i. Okay, and then again, my real part, the only real part is negative 6, and then 3i minus 4i is minus I. Done. All right, so adding and subtracting, no big deal. It's just like combining like terms. Multiplying. Multiplying is also a lot like multiplying a regular expression. You're going to do your distributive property, double distributive property. The only thing that you have to remember is that I squared equals negative 1. So I'm going to do a distributive property here. 2 times 5 is 10. 2 times 2i is 4i. Distribute here. 3i times 5 is 15i. 3i times 2i is going to be plus 6i squared. All right, and then the part that you have to remember, and this is where people get these wrong all the time, I squared is the same thing as negative 1. So 6 times negative 1, that's going to be negative 6. All right, so I can combine these two together, make that 19i, and I've got this 10 in the front. So it's 10 plus 19i minus 6, but then I can combine the 10 and the minus 6, right? So this is just going to work out to 4 plus 19i, and that's my answer. All right, so let's do the same thing again with this next one. So double distributive property, 5 times 5 is 25. 5 times negative 3i is negative 15i. 3i times 5 is positive 15i. And then 3i times negative 3i is negative 9i squared. Okay, so again, you've got to remember that this is the same as negative 1. So that's negative 9 times negative 1, which is going to work out to plus 9. All right, and then for the rest of it, these guys actually cancel each other out, so that's convenient. So I'm just left with the 25, and then 29 plus 5 is 34. So there you go. Take a quick note to yourself, right, that when we were doing these, I just multiplied two imaginary numbers together and got a number that's not imaginary. So product of two imaginary numbers is not always imaginary. Interesting. All right, so that's the thing. Now, there's something special about this one because I ended up getting that not imaginary number. So this is going to be where this thing called a complex conjugate comes into play. We are going to loop back to that idea in just a minute. Okay, so we're going to talk about dividing first, and then we're going to talk about dividing with complex conjugates. We'll come back and talk about that there. Okay, so skip that for right now. So dividing. Dividing, not too bad. This is like a lot like simplifying with radicals. Okay, so it's a lot like simplifying when you have radicals in your equation. So this first guy here, what I'm going to do is you can just simplify this. This I and that I will cancel each other out. They're common factors, right? And then 10 divided by 8, that simplifies to 5/4. Done. All right, so that was easy enough. Now, this guy here, we've got a problem because this one has an I in the bottom. And remember, by definition, I is the square root of negative 1. Okay, well, you're not allowed to have square roots in denominators of fractions. That's a thing. So we need to rationalize this. How am I going to do that? Well, I'm going to multiply top and bottom by I. Okay, because what that's going to do is now when I look at the denominator of my fraction, sorry, I'm choosing the right color. It's a hard choice. Right? Now when I look at the denominator, I'm going to get negative 3i squared. And like we talked about before, I squared, that's the same thing as negative 1. So now I've got negative 3 times negative 1, that's positive 3. Right? So by multiplying by I top and bottom, I canceled out the imaginary part. And then meanwhile on the top, 4 times I is 4i. Okay, so that's my simplified rational expression here. Okay, this guy right here, I'm going to do the same thing. I need to multiply by I, top and bottom. Notice that I'm not multiplying by 2i. It doesn't have to be exactly the same thing. You just want to set it up so that you're going to get rid of those i's. Okay, and then what's going to happen? Well, in the top part, sorry, I'm really like struggling to choose the right colors here. And I know that sounds stupid, but it's a weird quirk of my personality. Okay, so sorry. On the top part, I'm going to have negative 8i to the third power. Okay, and then I'm thinking to myself, all right, what's that pattern again? Oh, right. So I to the third power would be negative I. So up in the top, I've got this negative 8, and then that will work out to negative I. So negative 8 times negative I, that's positive 8i. And on the bottom, I've got 2 times I squared, so that's negative 2. And then we can simplify that to negative 4i, 8 divided by negative 2. And there we go. Excellent. All right, this guy here, simplifying this. So this guy, just like how we could cancel out the i's here, you can cancel out the negatives here. Okay, so I'm going to simplify that rational fraction just like we would if we were simplifying regular rationals, right? So I'm going to go ahead and simplify this to 2 times the square root of 1 over the square root of 3, right? Common factor of negative 5 that I pulled out. Obviously, I don't need to keep that square root of 3, the square root of 1 at the top. But I do need to rationalize this. So I'll multiply top and bottom by root 3. And that's going to give me 2 root 3 over 3. All right, these last two, take note of these two problems. They are different. Okay, this one, the multiplication comes first, right? Order of operations, you multiply first and then do your grouping symbol, which is what the square root is. This guy, right, your order of operations says do the grouping symbols first, the square rooting first, and then multiply. Okay, so there's a difference between these two problems. When you look at this guy, you'd multiply first, and negative 2 times negative 8 is positive 16, so your answer's 4. Okay, but on this guy, because they're separate square roots, the first thing you have to do is pull the i's out. So you're going to make this I root 2 times I root 8, which is I squared root 16. And then I squared is negative 1, so that's negative 4. So notice that we got different answers to these two problems. That's really important. You've got to watch out for what order you're doing it in. If they're separate radicals, then you got to deal with the I situation. But if it's one big radical and you're multiplying on the inside, then you don't have to worry about it. Okay, so that's simple dividing. Now we've got this idea of complex conjugates. Okay, so let's scroll back up here really quick. Remember this problem where we multiplied them together and we multiplied two imaginary numbers and we ended up with a real number? That is because these are something called complex conjugates. Okay, so they're complex conjugates, and what that means is that they have the same real part, okay, and the same imaginary part, but an opposite sign. One's a plus, one's a minus. Okay, so that's what complex conjugates are. Two complex numbers with equal real parts and imaginary parts. Okay, but opposite signs. So one's a plus and one's a minus. All right, and that is convenient because it gives us a way to rationalize some more complex fractions. This guy right here, if I were to just multiply this by I, top and bottom, I'd have to do a distributive property on the bottom, and I'd end up with a 2i and then an I squared, and I'd still have an I there. right? So that causes me some issues. So what this complex conjugate thing is it's a trick that you can use so that when you multiply this denominator, it'll become something that's real. And then we won't have that imaginary number in our denominator anymore. Okay, so I'm going to do this guy. I'm going to multiply top and bottom by the complex conjugate of the denominator. So in this case, it would be 2 minus I. Okay, so same real part, same imaginary part, different sign. Same thing here. I'm going to multiply by 2 minus I. All right, I do still have to do my distributive properties. So on the top, I'm going to end up with 6 minus 3I. On the bottom, 2 times 2 is 4. And then I'm going to get a minus 2I. And then I'm going to get a plus 2I. And then I'm going to get a minus I squared. Okay, great. Well, this is negative 1. And this cancels out, right? So there you go. All my imaginary numbers are gone. So what I have now is I've got 6 minus 3I on the top. And on the bottom, I've got a 4 still. And then minus negative 1. So plus 1. So this is 6 minus 3I over 5. Okay, and now I don't have anything imaginary in the denominator anymore. All right, so this guy, same deal. I'm multiplying by the complex conjugate. So I'm looking at the denominator. The numerator's fine. We can have imaginary numbers there. But the denominator, I'm going to use 4 plus I. Okay, so opposite signs. And notice that these are exactly the same, right? If you're going to do something to the top, you have to do it to the bottom too. All right, so now let's multiply this one out. So again, double distributive properties. So on the top, I'm going to have 12, right? And then plus 3I, and then plus 8I, and then plus 2I squared. Ooh, barely fit that. On the bottom, I'm going to have 4 times 4 is 16. Then I'm going to have a plus 4I, and a minus 4I, and then a minus I squared. All right, these guys cancel. I've got a negative 1 here and a negative 1 there. Those don't cancel. All right, so where does that leave me? So on the top part, I'm going to have a 12, and then it'll end up being minus 2. So that'll be 10. And then 3I plus 8I is 11I. On the bottom, I'm going to have 16 and then minus negative 1, so 17. And these guys canceled out. So that's it. That's my answer. Okay, so that's how you use a complex conjugate. This is one of the areas that people struggle with more. I tend to see mistakes on these types of problems. Okay, so make sure you just spend a little extra time making sure you're really solid with those. Definitely check your answers. All right, and then last but not least, solving equations with imaginary numbers. This is no big deal. Okay, so we're going to solve this like normal with square roots. So I'm going to divide both sides by negative 2. X squared equals 5 over negative 2. Square root both sides, positive or negative, square root of 5 over square root of negative 2. Okay, and then I need to rationalize this. Okay, and you've got to be careful about how you're going to rationalize this. So the first thing I'm going to do is I'm going to rewrite this as root 5 over I root 2. Okay, so then when I go to rationalize it, I'm multiplying top and bottom by an I to get rid of the I, and then a root 2 to get rid of the root 2. Okay, so that's going to give me positive or negative I root 10 over, well, this will multiply to 2, and that'll multiply to negative 1, right? So negative 2. That's my answer. Oh, I changed colors. This should have been in the pink, right? Because that was an additional thing, so it's a different color, but I should have switched back to pink. See, these are the things that I stress about that are totally unnecessary. This is the exact same answer, but I'm trying to rewrite it. Oh, this isn't the right color. I put down the marker, and now I'm not sure which one I used. These are the stupid little things that I obsess about. There we go. Now it matches. That's your answer. All right, last guy here. So solving this one, step 1, divide by 3. So I'm going to have x minus 4 squared equals negative 16. right? Square root both sides, so x minus 4 equals positive or negative 4i. And then add the 4 to both sides, so it'll be 4 plus or minus 4i. And that's it. Okay, so solving, not that big of a deal. It's just kind of tying stuff in. Okay, so generally this part, pretty easy. This part, pretty easy. This part, pretty easy. This part, maybe a little bit harder. This is the doozy though. This one's the part that tricks people up. Okay, so complex conjugates, really important. Same number at the front, same number at the end, opposite sides.